So, my dear students, very good morning. And today we are going to discuss the continuation of the coordination compounds. And you know that we already completed the VBT theory for the square planar, tetrahedral, and octahedral complexes. Now, after the VBT theory for the different complexes, the next one which is isomerism, that is in the complexes. We have to see the complexes isomerism that we must see in this lecture. Now let us understand what actually the isomerism is. So what is isomerism? Actually, the isomerism is nothing but you know that you have already studied in the last semester, that is the stereochemistry of the carbon compounds. You already studied that in isomerism, that is a functional group isomerism or whatever may be in case of the optical isomerism like DL configuration, RS configuration, that you have already studied in the organic chemistry, the stereochemistry of the carbon compounds. Now, but you have to study the isomerism which is in our inorganic complexes. Let us understand one by one. So see here. So what actually isomerism? See here. So isomerism, what is actually isomerism? That is the same molecular formula but different properties, so what actually the properties, what type of properties here? So whatever may be, there may be a same molecular formula but a different properties. So you have already studied this in case of organic chemistry. So in case of the organic chemistry, you have studied, you know that very simple example. Let us take some simple example like this. Sorry, I want to write another example, that is CH3, C double bond O, CH3. This is one example. CH3, CH2, C double bond O, H. So you can see here what is actually the difference between this one and this one. So observe here. So what is actually difference here in case of this compound and in case of this compound? You know what is the name of this compound? This is a acetone. This is acetone. That is in the organic chemistry you have studied. That is, or you can also call it as a propanone. Propanone, because three carbons are there and the functional group which is ketone. And here also which is aldehyde here. So what is aldehyde here? So see here. So this is the this is a propanone and this one is acetaldehyde. You can also this is aldehyde because aldehyde group is there. So we can also call as a acetaldehyde. Or you can say that this is a propanaldehyde. Propanaldehyde. So what is actually the difference between these two? The functional group which is different. But you can check the molecular formula, both are same here. So three carbons are there. So C3 and H, there are six carbons are there, sorry, six hydrogens are there and one oxygen is there. So the molecular formula is there, molecular formula is same, but it is different in their properties. So where actually the difference here? So you can see here. So this is acetone, the ketone group here. See here. So see here. So this acetone, which is a ketone group, functional group, and this is aldehyde functional group. So there is a difference in the functional group, but the molecular formula is C3H6O. So here the molecular formula is same, but there is a different properties. The different properties. What actually this is due to change in the structure or change in the orientation of groups that we will study in this lecture. So that you have already studied in the organic chemistry, but now you have to study in the inorganic coordination complexes. So what is actually isomerism? From basics, we will start with the isomerism. So let us understand these things. So let us take first what is isomerism. So isomerism is nothing but it is a molecular formula must be same and there is a difference in their properties. I will tell you one physical example so that you can easily understand. So this example you can see here. So you know that who is this? The person. You know that he is a UPCM, that is a Yogi Adityanath. You know, everyone you know that. His name is Yogi Adityanath. Sorry. Okay. This one. So see here. So the person, he is a Yogi Adityanath. He is a UPCM. You know that Yogi Adityanath. And this person, this person is Yogi Adityanath. And who is this? The person, his name is Vin Diesel. So who is this? I think you know familiar this person because he is a American. Actually, he is an actor. He is an English actor, Hollywood actor, and his name is Vin Diesel. And you can see in his films like Fast and Furious. I think most of the students, you can see the Fast and Furious movie. There are something 9 to 10 parts are there. So in that movie, he is a hero. He is an actor. So you can see here both. You can see this picture. So let us see first this picture. So this one and this one. So see here, what is the difference between these two pictures here? The persons are different. His name is Yogi Adityanath and his name is Vin Diesel. So the persons both are different. Both are different. But you can see here, it looks like same. It looks like same. But it looks like same, but the properties are different. So here same molecular formula, but different properties are there. That means here he is actually, who is this? He is a Yogi Adityanath. He is a politician. He is a politician here. So he is a politician means, sorry, he is a politician. He is a politician, that is a UPCM, and he is an actor. He is an actor. So here the professions are different, but they are looking exactly the same. So they are looking same because you can see here. So you can see like this, whatever may be the structure are in looking. So both are, it looks like same, but the profession is different. That means same molecular formula, but it is different with the properties. So it is different with the properties. So both the, actually his face and his face, both are something, they are looking like same, but the properties are different. So why the properties are different? Here the properties are, he is a politician, he is an actor, Hollywood actor. So both are different. The professions are different. That means the properties are different. So in that way, same you can say in the organic chemistry, you will have this type of example. You have a simple example like CH3, C double bond O, CH3. That is a molecular formula will be C3 H6O. And here also you can take CH3 CH2 C double bond O H. This is also same C3 H6O. Here the molecular formula is this one and this one. Both are same, like like them here. Here also you can see both the molecular formulas are same, but that is a difference in their structure, difference with the properties. The properties of ketone, the properties of aldehyde, that is completely different. Now we have to see this type of isomerism in the inorganic metal complexes. So let us understand in the inorganic metal complexes what is isomerism, so, and why the different properties will exist. So why actually the different properties will exist in different complexes. So let us understand so that you can easily understand here. So see here. So actually the same molecular formula, but there is a difference in their structure. So difference in their properties. So why actually, what is the why it is getting the different properties? This is due to this is due to this is due to in two ways, that is a change in the structure or change in the orientation of groups. So change in the structure. Just now only I told you in case of aldehyde and ketone, that is in case of organic chemistry. But now we have to study in the coordination compounds. There is a change in the structure, which is also called structural isomerism, and there is a change in the orientation of groups, that is a stereoisomerism. So you know that in the organic chemistry, that is in the third semester, I think you have already completed many such examples. You can take like, I will take one example so you can easily understand. So, fluorine, chlorine, Let us take this bromine and this iodine. Let us take this chlorine, and this is bromine, and this is iodine. So you can see actually what is the difference here. The bromine and chlorine, they are different here. Here the bromine which is out of the face, that means it is a back of the plane, and this is the iodine which is front on the plane. So a plane ki front on an iodine, the bromine which is back side of the plane, and here the iodine is which is back side on the plane, and the bromine which is front side of the plane. So here the orientation is different. That means the position, the orientation of iodine and bromine which is different, but the molecular formula is same. This you will study in the organic chemistry, that is a stereoisomerism. So you know that the molecular formula is same, but there is a different properties. The properties are due to change in the structure or change in the orientation of groups. So we have already studied so that the change in the structure and the change in the orientation in earlier classes, that is in case of organic chemistry you have studied. So now we will discuss. Today we are going to discuss the structural isomerism and stereoisomerism in case of the inorganic coordination complexes. So let us understand one by one. So see here. So let us understand the isomerism in the coordination compounds. So let us understand what is actually isomerism in case of the coordination compound. So in case of the organic chemistry, see the isomerism which is completely same. There is no difference. The types of the isomerism both are same. But we have to study that structural and the stereoisomerism in case of the complexes. Let us understand first the isomerism is classified into two types, that is the structural isomerism and the stereoisomerism. So just now only I told you that. So there is a same molecular formula, but different in the properties, The properties are different due to there is a change in the structure or there is a change in the stereo. That means the orientation of groups. So the structural isomerism and the stereoisomerism. There is a two classification in case of the isomerism. So again, the stereoisomerism is classified into two types as geometrical isomerism and another one which is optical isomerism. Now in this today we are going to discuss only the structural isomerism in case of these complexes. So let us understand one by one. So see here. So structural isomerism. So what is actually the structural isomerism? The structural isomerism which is classified into these five types. That is the ionization isomerism, hydrate isomerism, position isomerism, coordination isomerism, ligand isomerism, and again the coordination position isomerism. So let us understand one by one what is structural isomerism. So I already told you that. So what is actually isomerism? That is the same molecular formula, same molecular formula, but different that different property, but these properties different due to change in the structure of the complex, due to change in the structure of the complex. Hence it is called the structural isomerism. So let us understand what is structural isomerism. So that means something, there is a two complexes are there, both are structurally isomers. That means both are same molecular formula, but the difference in their structure. So because of the structural change, there is a change in the physical property. That means one complex may show red color, one complex may show blue color, whatever may be. Let us take one and two. These are the two complexes, and both are having the same molecular formula, but there is a difference in their structure. So the structure it may be different, and it may show different physical property. It may show red color and it may show blue color, whatever may be the colors, the physical properties, but here the properties are different due to change in the structure. Hence it is called structural isomerism. So this structural isomerism is classified into these five types. So let us understand one by one what is these structural isomers. So let us understand what is actually this isomers. So see here, structural isomers. So just now only I told you that the isomers are classified. Sorry. The isomers are classified into two types as structural and stereoisomerism. That is ionization isomerism, hydrate isomerism, and linkage isomerism, and coordination ligand isomerism and coordination position isomerism. These are the five types you have to study in this structural isomerism. And the stereoisomerism I will tell you later. So now we will understand only the structural isomerism. So let us take the first one, that is the ionization isomerism. So what is actually ionization isomerism? Ionization isomerism. What is ionization isomerism here? That means there is a different. So what actually here there should be same molecular formula. So these are the isomers. So there should be same molecular formula, but difference in their structure. Hence, they are called structural isomers. Structural isomers అంటేనే same molecular formula ఉంది, but the structure is different. So you can see what actually the structures. Let us take one example. ఒక example తీసుకుందాం చూడండి. Let us take simple example CO Br NH3 taken 5, and here I will write as sulfate. And I will take the another example, that is CO, sorry, and I will take SO4 as inside, and I will write again NH3 taken 5 times, and I will write Br on outside. So let us understand here. What is the difference between these two complexes? Here this is a cobalt and this is a bromine. Here one bromine is there, here one bromine is there, and 5 ammonia molecules are there. Here also you can check, here one sulfate and here 5 bromines are there. So you can see here one cobalt, here one cobalt, one sulfate, one sulfate. Totally both the molecular formula are same. Molecular formula of these two complexes both are same. But there is change in the physical properties. So this is due to difference in their structure. So actually you can see here there is a change in the structure. There is a change in the structure. You can see here, where is the structural change here? See here the bromine which is here, which is inside the coordination sphere. That means this bromine is donating its lone pair of electrons to the cobalt. Here sulfate, it is outside of the coordination sphere. That means it is not a dative bond, it is simply an ionic bond. So it cannot donate its lone pair of electrons. So it is indicated with a dotted lines. That means here you can see here the sulfate is donating its lone pair of electrons. But here in case of this, so here it is donating this bromine which is not donating its lone pairs here. Now you should understand here there is a change in the structure of these two complexes. And what actually there is a change here? So here bromine is there, and here inside the which is sulfate is there. Sulfate group is there. Here the outside of the sphere sulfate group is there. Here the bromine is there. So these such type of isomers are called ionization isomers. So why these two isomers are called ionization isomers? Why they are called ionization isomers? So why because there is a change in the ionization. There is a change in the isomerization. So there is a change in the ionization. So what is actually the ionization? So that you should understand here. So you can see here how the ionization will happen. Generally, to occur the ionization. What is ionization? Simply the whatever the generation of ion, that is a cation and the anion. So cation, anion, the production of cation and anion, you will get the ionization. The term which is ionization. So you can see here. So here the sulfate which is making the ionic bond here, because this bromine which is already involved in a dative bonding, that is a coordinate covalent bond. But here the sulfate which is making the dative bond, but here the bromine is our ionic bond. So when you react with AgNO3, you can take, let us take AgNO3. So when AgNO3, so the AgNO3 when it reacts with these two complexes, it can easily reacts with these complexes and it will form as a AgBr. It can easily release AgBr. So AgBr, actually this is a light yellow color precipitate. This is light yellow precipitate. అంటే ఏం లేదు నాన్న. సో ఉదాహరణకి ఇఫ్ ఐ am టేకింగ్, సో నేను ఏం చేస్తా అంటే చూడన్న. సో లెట్ us టేక్ వన్ ఎగ్జాంపుల్. సో నేను ఏం చేస్తా అంటే నేను ఏజీబీఆర్ తీసుకుంటా, సారీ ఏజీఎన్ఓ3 తీసుకుంటాను. ఏజీఎన్ఓ3. సో ఏజీఎన్ఓ3 సొల్యూషన్ తీసుకొని దీన్ని కలిపిస్తున్నాను. సో కలిపేగానే ఏమవుతుందంటే ఐ విల్ గెట్ లైట్ ఎల్లో కలర్ ప్రెసిపిటేట్. ఎల్లో కలర్ వస్తుందన్న, లైట్ ఎల్లో కలర్ పీపీటీ వచ్చేస్తుంది ఏది దీనికి కలిపితే. మరి వాట్ అబౌట్ దిస్? దీనికి కలిపితే రాదు నాన్న, దీనికి కలిపితే ఎల్లో పీపీటీ అసలు రాదు, రియాక్షన్ అనేది జరగదు. సో రియాక్షన్ అనేది దానికి జరగదు నాన్న. మరి ఎందుకు జరగదు అంటే హియర్ దిస్ ఏజీ యూ కెన్ సీ హియర్ ద బ్రోమిన్, యు నో దట్ ద ఆక్సిడేషన్ స్టేట్ ఆఫ్ బ్రోమిన్, దిస్ is -1 here and this is +1 here, you know that. So here -1. So in case of AgNO3 you can, there is here Ag plus and NO3 minus. You know that the AgNO3 can be easily divided into Ag plus and NO3 minus. So here Ag plus is there. So Ag plus and it reacts with this Br minus and it forms as a AgBr, so that it can easily produce AgBr as yellow precipitate. So that you should understand here. So whenever AgNO3, when it reacts with the below compound, so whenever it reacts with this below compound, you know that you will get a yellow PPT like this. But here in case of the first complex, this first complex, it cannot get the yellow PPT when it reacts with the AgNO3. And what about the it? What when you take? I will take the another example. So I will take the another solution, not AgNO3. I will take a different. I will take a different reagent. So what is actually the different reagent? So simply I will take the barium sulfate. So first I will take the barium sulfate. Sorry, barium chloride. I will take BaCl2. So when BaCl2, when it reacts with these two complexes, it can easily reacts with this first complex and it can produce easily barium sulfate. Barium sulfate, which is actually, this is a white precipitate. White precipitate here, white PPT here. It will produce white precipitate here. అంటే ఏం లేదు నాన్న, బేరియం క్లోరైడ్ సొల్యూషన్ తీసుకొని నేను దీన్ని కలిపితే when it reacts with the first complex, it can easily produce white precipitate. ఎందుకు అంటే here the sulfate which is -2 here and this is +2. And now this barium, this is barium +2 and Cl -2 here. So this barium +2, when it reacts with this sulfate, and it can produce barium sulfate, and it is white in color, white precipitate you will generate here. But when it reacts with this barium chloride with this, but it cannot react with this barium chloride, because here the bromine which is -1 here, and there is we are reacting with the barium chloride. In case of barium chloride, we are having barium which is in +2, but here this is a -1 here. So if it is -2, then it can easily react with the barium, but here it is -1 here, and here +2 is there. There is a difference, there is no neutralization happen, hence the ionization will not occur here. So the ionization will occur. So you can see here that you can easily understand the isomerism here. So when you take the ionization isomerism, so I will remove all these things. So see here. So you can see here, these two isomers are called ionization isomerism. They are called ionization isomers. So why they are called specially ionization isomers? Because they are the isomers which are having the same molecular formula. You can check here, both are having the same molecular formula, but there is a difference in their structure, and the structure is also different in their ionization property. Here it can release only, can easily react this particular first complex, it can easily react with the barium chloride, but it cannot react with the AgNO3. AgNO3 ni asal react avvadu, but in case of barium chloride it can easily react with this. And here in case of this, it can easily react with the AgCl, sorry, AgNO3, it can easily react with the AgNO3, but it cannot react with again barium chloride, it cannot react with the barium chloride. So that means you should understand that there is a change in the physical property. There is a change in the physical property, that is due to the change in the ionization. So here the ionization different here. So why actually the ionization here different here? So you can easily understand here. There is a change in the ionization. So where is actually the change in the ionization? So in case of the second complex, you can check here. So in case of the second complex, that is a bromine is ionized here. So here the plus one here and minus one here. That means here you will get bromine minus and totally you will get plus here. But in case of this sulfate, which is sulfate minus 2 here, that is a plus 2. You can check here the ionized, whatever the ionized form, that ionic species, this is here sulfate. But here the ionized species, this is a bromine. So it can only react with our AgNO3, and the sulfate it can easily react with the barium chloride. Hence, the physical properties are changing here. So that is due to ionization. There is a change in the ionization. Hence, such a type of isomers are called ionization isomers. So the phenomenon is called ionization isomerism. You can take many such example. You can take this. You can take this example. So see here. Here there is a platinum. There is a platinum, and this when it is two chlorines are there, and you will write it, four ammonias are there. You can write like this, Br2. And see here I will write simply like this. I will write Br2 here, and I will write NH3 taken 4, and I will write like this. So what is the difference between these two complexes? The bromine, which is outside of the sphere, and when it is reacting with AgNO3, it can produce 2 moles of AgBr, and that is a yellow color PPT. It will get the light yellow precipitate. But when it react with this particular complex, when it is reacting with this AgNO3, that it can produce 2 moles of AgCl, and the silver chloride which is in white color. So that means the second complex will form a white color AgCl. But in case of the first complex, it will produce AgBr, that is a light yellow precipitate here. So there is a change in the physical property. This is due to only change in the ionization. Hence, such type of isomers are called ionization isomers here. You can take such many examples. You can take a lot of examples. See here. So there is also another example, that is CO, that is COCl2 and NH3 taken 4 times, NH3 4 times, and here I have written NO2, and here again I will write Cl NO2, and I will write another chlorine, and I will write again NH3 taken 4 times, and I will remove one chlorine outside like this. I will write like this. So you can check here, there is no change in the molecular formula. Both are having the same molecular formula, but the difference is there in their ionization. Only the difference in their ionization. So here NO2 is there. So here you will get only NO2 minus here. Here only Cl is there, Cl minus is there. So that means you can easily understand that when it is reacting with AgNO3, it can easily react with AgNO3. It can easily react with AgNO3, and it can easily produce AgCl as precipitate. That is a white color precipitate. But when it is reacting with this particular first complex, AgNO2, it doesn't form as much as easy as AgCl. AgCl it can easily produce when comparing with this NO2 here. So this type of complexes are called ionization isomers. So these are all example, and you can see in the textbooks, and you can also study those examples. And let us take another example. So this one of the isomerism, the classification of structural isomerism, which is ionization isomerism. The next one, which is, so the next one, see here. So the hydrate isomerism. So hydrate isomerism. Sorry. So see here. So this next one, which is hydrate isomerism. So what is actually the isomerism here? So there is a hydrate isomerism. So what is hydrate isomerism? So the hydrate isomerism, you know that the hydrate is nothing but water. So the water is completely different here. So water is completely different here. So I think you have already studied many such example in your earlier classes. The water can form as a hydrates. So you can call it as also water of crystallization. Water of crystallization. So many of the complexes, most of the compounds, those hydrates are completely crystals. Those hydrates are completely crystals. So you know that the gypsum. So that is a gypsum, that is copper sulfate, CuSO4, that is 7H2O, or sometimes that is half H2O. different there is a different compounds are there. So here H2O, that is 7 H2O, that means so H2O, it doesn't breaks as H plus and H minus. It doesn't breaks as H plus and H minus. అంటే ఇక్కడ హైడ్రేట్ అంటే ఏంది నాన్న? H2O. You can see this example. ఒక ఎగ్జాంపుల్ చూడండి నాన్న, మీకు ఈజీగా అర్థమవుతుంది. So let us take this example, that is a chromium and H2O taken 5, and I have written Cl2, and here I have written H2O. So you can easily understand here that this H2O, this is a hydrate. That means it is also called water of crystallization. Water of crystallization. This is also called water of crystallization. That means it doesn't breaks. That means it doesn't break down into ions as H plus and OH minus. ఇలా అసలు విడిపోతున్నాను ఎప్పుడు కూడా అవి రెండు కలిసి కట్టుకునే ఉండి ఇట్ కెన్ ఫార్మ్ ఓన్లీ ద H2O అలా మాత్రమే ఫామ్ అవుతున్నాను. సో దాన్ని హైడ్రేట్స్ అంటారు, వాటర్ ఆఫ్ క్రిస్టలైజేషన్ అని కూడా అంటారు. సో యూ కెన్ సీ హియర్ వాట్ ఈస్ ద డిఫరెన్స్ బిట్వీన్ దీస్ టూ కాంప్లెక్సెస్. You can see here, you can check these two particular complexes. One is the Cr, and that is a chromium, that is H2O taken 6, and again that is a chlorine which is Cl3, and I will write another one, that is a Cl2 H2O5, and one of the chlorine which I should write like here, and I will write again Cl2, and one H2O I will write outside. And you can take such many examples. Cr H2O I will write 4, and I will write Cl2, and I will write 2 moles of H2O here. So what is actually the difference between all these examples? You can easily understand here. First, this second one, and this third one. So what is actually the difference? The molecular formula is same, but the difference in their structure, and the structure is also different with their hydrates. So ఇక్కడ H2O తీసుకుంటే ఒక్కటే ఉందారన్న, H2O ఆరు ఉన్నాయి, but they are the ligands. They are the ligand. Inside of the coordination pairs, they are the ligands. They can easily donate their lone pairs to the central metal ion. But the outside of the sphere, there is no H2O ligand. That means this is not forming as a water of crystallization. So it doesn't form as a hydrate. But you can check here, it is forming one hydrate molecule here. H2O is there, and it is producing two hydrate molecules are there here. So such type of isomers are called hydrate isomers here. So that means there is a same molecular formula, there is a difference in their property. So what is actually the property? You can easily understand the colors. So color of the first complex, which is actually this violet color, and the second complex which is green color, and the third complex which is dark green color. So you can take such many examples. So they all are having the same molecular formula, but there is a change in the physical property, that is change due to the change in the hydrates. This is also very important. So if there is a change in the hydrate, and then the physical property will also change. Such type of isomers are called hydrate isomers. And next, let us see the linkage linkage isomerism. So this is also very simple example. That is, you can take this example CO, and I will write NH3. I will take here CO, and I will write NH3, and I will write taken 5 here, and I am writing ONO. I will take this complex, and I will take the another complexes CO, NH3 taken 5, and here I will write NO2, and I will write like this. So what is actually the difference between these two here? I will write +2 and +2. So what is actually the difference between these two here? So you can easily understand here. So what is actually the difference between this linkage isomerism? So in case of this linkage isomerism, what actually happens? The linkage of the atom, linkage of the ligand, which is different. So see here, what is the ligands here? There are 5 ammonia ligands are there. 5 ammonia ligands are there. In case of the first complex and the second complex, both are having the 5 ammonia ligands. So there is no change. But in case of this ONO here, and this is NO2, there is a change in the ligand. So both are actually the only one ligand, but it is a it is an ambidendant ligand. So if it is ambidendant ligand, so it can donate through 2 donor atoms. So you can, what is the structure of actually the NO2? NO2 you can check here, ONO. How to write the structure here? You can write like this, like this. You can write like this. ONO. See here, ONO minus. So you can write NO2, NO2. You can write like this. NO2. So that means there is a lone pair on the nitrogen and even also on the oxygen. So oxygen can also donate because it is having the excess negative charge. So it can donate also through the oxygen. And this nitrogen is also having one lone pair. So nitrogen can also donate its lone pair to central metal ion. So that means both are actually this and this. Both are same actually. It is donating through the oxygen atom. But here it is donating to the nitrogen atom. Both are same molecular formula, but the difference is with the linkage. Here it is linked with the oxygen. Here it is linked with the oxygen, but here it is linked with the nitrogen. So the color of this particular example, this is red color and this is yellow color. This is yellow in color. That means there is a change in the physical properties. The physical properties, the change in the physical properties, completely it is due to the change in the linkage of the donor atom. The ambidextrant ligands are generally they are having different linkages with the metal atom. So here NO2 which is donating its lone pairs through oxygen atom, but here it is donating through the nitrogen atom. So there are many such example. You can take many such example. So you can take here, so you can take this example like palladium dipyridine SCN and here NCS. So SCN is different with the NCS. NCS. So you can see here what is actually the difference. So, so I will write like this minus. So here also I will write minus. So see here SCN and here NCS. So here also it can donate through nitrogen atom and one sulfur atom. So because sulfur is also having the lone pair of electrons and here the nitrogen is also having the excess negative charged electrons, hence it can donate through here. Here let us take it may be donated through the nitrogen atom or it may be donated through the sulfur atom here. Such type of ligands are called ambidentate ligands. So they are the type of isomers are called linkage isomerism. Such type of isomers are called linkage isomerism. So let us understand all these things. So now let us understand the coordination ligand isomerism. Coordination ligand isomerism. So these examples were very rare actually, but you can write in the exams. So see here. So I will take one example that is a platinum, that is platinum NH3 taken 4 and CuCl4. So you can check here. So actually there is you can understand here. So this is completely whole one particular complex. So I will write totally so you can easily understand. So the platinum NH3 taken 4 and I will write CuCl4 and Cu. So the difference CuNH3 4 and platinum Cl4. You can check here what is the difference between these two complex. So here there are the double brackets are there. So actually both are only one coordination complex. These are the rare complexes that you will study in higher studies, but you must understand here. So this double complex we see here. Here the platinum is coordinated with this four ammonia ligands, and here copper is coordinated with the four chlorine ligands. But here you can see the difference. Here the copper is linked with the ammonia atom and here the platinum is linked with the chlorine atom. There is a change in the ligand isomerism. There is a change in the ligand isomerism. The change in the ligands. Here the platinum is coordinated with ammonia ligand, but here the copper is connected with the ammonia ligand. But here the copper is linked with the chlorine atoms. But in case of this complex, the copper is combined with our four ammonia ligands. So that such type of isomers are called coordination ligand isomers. You can take many such examples. So see here, platinum NH3, and here this NH3 and Cl, they are exchanged. And you can take this ammonia and cyanide, they are also exchanged. They are also exchanged. I will send you notes so that you can easily understand all these things. So next you can see here. So the last isomerism. This is also isomerism is very very important. So see here. So coordination position isomerism. So coordination position isomerism is also it is also very very simple to understand. Here the position of the ligand position is completely different. You can see here three ammonia ligands are there. Here the three ammonia ligands with one chlorine. So you can easily understand here three ammonia and here one chlorine. Here also three ammonia and one chlorine. That means this is our octahedral complex. There are six ligands. So here three plus one, here four, and there are the two other ligands. So totally six coordinated complex here. So this cobalt here, cobalt, this is three ammonia ligands, and here also three ammonia ligands. So what about this? Here the ammonia ligands are only two here. Here this is four here. That means what actually happens here? So what actually happens here? So why what actually happens here? Here three ammonia ligands are there. Here also three ammonia ligands are there. And here one chlorine atom. Here also one chlorine atom. But in case of the second complex, one of the NH3 will come to this side, and to make here 4 here and here 2 here. So see here NH3 only 2 are there, but here NH3 here 4 is there. That means the position of the ammonia ligand is different here. The position of ammonia. So the position of ammonia is completely different. Here the position of ammonia is here first this side, but here it is moving to this side. So you can check here. So you can check this side. So ammonia is moving towards to this. So the position of the ligand is completely different. Hence, such type of isomers are called position isomers or coordination position isomers that you have to study it in case of this structural isomers. Next, we will see for the stereoisomerism. But before this, you need to understand all these things. So there are five types of isomers. So just now only I told you that those different example, that is the ionization isomerism. Sorry, that is the ionization isomerism, hydrate isomerism, position isomerism, coordination ligand isomerism, coordination position isomerism. All these are very very important that you have studied in case of this structural isomers. That means I already told you that there is a change, there is a same molecular formula. There is a same molecular formula, but difference in their structure. ఆ స్ట్రక్చర్ లో కూడా మళ్ళీ ఏం చేంజ్ ఉంది అంటే అయనైజేషన్ లో అయనైజేషన్ చేంజ్ ఉంటుంది, హైడ్రేట్ లో వాటర్ చేంజ్ ఉంటుంది. పొజిషన్ ఆఫ్ లిగాండ్స్, sorry, this is not a position isomerism. So write this as a linkage isomerism. This is not position. You can type that is a linkage isomerism because the linkage of the donor atom, the ambidynamic ligands are completely different. So the linkage isomerism or the coordination ligand isomerism or coordination position isomerism. So these are the classification of the structural isomers. Now after this we will see the further the stereoisomers. Okay.